Week. All right. So I had mentioned on Friday how I thought what we were starting on Friday, continuing today and tomorrow and Wednesday, is the hardest stuff we're going to do all year. What do you guys think on Friday? And your homework?
Sarcasm.
Easy, not hard. Drake even asked me, Mrs. Ritz, were you being sarcastic? I was not. I do think that when we get to some parts of this, that you will find it to be kind of difficult, but the fact that you guys all found what we were doing on Friday pretty easy is great news, because that's half of the hardest stuff we're going to do all year, and you all aced it or got really close to acing it. You all thought it was easy. And that's exactly what I want you to do. I want to make sure you know how to do each one of these chunks that we're going to do. If you know how to do each one of them, then you really know what's going on, and it'll be perfect and you'll get it and you'll be awesome at it. We just need to then practice like the next part, which will be okay. As long as you know what you were doing Friday and then what you had to do today, you will be okay. I promise. But I was not being sarcastic. So the fact that you're acing it so far makes me hopeful. So just a reminder of what we did on Friday. Now, I gave you those big reference tables. If you find those big reference tables easier to use, just because they're blown up and you can see like exactly where that line is a little better, continue to use them. Or they're exactly the same as the reference table on page 11. So whatever floats your boat, go ahead and do that, okay? So I'm not going to force you to use the large one or force you to use the small one, but you have to use one of them. I will tell you though, on the Regents, that you have to use the small one. Unless, of course, you have some actual vision issues, and we can get you like a note that says you can use them in large copies. So unless that applies to you, you do have to use the small one. All right, so let's go through what we did on Friday and then go over the homework real quick. So just a reminder, on the top of page 21, when it said state how long it takes the P and S waves to travel the distances listed below. So for the top, so those of you who weren't here might want to pay attention, okay? So when they ask how far can a P wave or how long does it take a P wave to travel 7,000 kilometers? You went to 7,000, you went up till it hit the P line, and you read over, and it should have taken 10 minutes and 25 seconds. Mrs. Ritz. I can, yep. Okay, bye, Allison. So check Teams for what we're gonna do today, but there won't be any homework. So that again was 7,000 till you hit the P line, go over 10 minutes and 25 seconds. Phoenix, pay attention. And then if for the S wave, you do the same thing, 7,000, go, whoa, you make sure you don't do what I just did and let your hand drift away. You follow that 7,000 line up and you go directly over, and we had 19, just below 19 minutes for that one. Then we did what you were supposed to do for your homework. We went the other way, so that we already did the 4 minutes and 20 seconds together. Let's do the 12 minutes. So we went to 12 minutes and I said, well, how far can the P wave travel in 12 minutes? So you go over, you don't stop at the S wave because I only asked you about the P wave so far. You hit the line, you go down. I got 8,800. Did you guys all get that too for 12 minutes for the P wave? Anybody? Remy kind of acknowledged me speaking, but the rest of you are ignoring me. I got 8,800.
Yeah, I got.
Okay. Hang on. What do you mean? What would be the seconds?
How far would you go?
Oh, for the S wave, you mean? Or do you mean in seconds? We'll let you try a few and we'll see how you do first, okay? So then we had to do the same thing. So you had to go to 12 minutes. You go over till you hit the S wave this time and go down. I got 3,700. Did you guys also? You didn't like round it to 600 or 800 just to make life easier? Good. You should have had the 700. So let's just go through these kind of quickly here so we can get on to the next thing that's the hardest we're going to do all year. So again, we already did these top two now. So 2,200, 1,100, 8,800, 3,700. And then don't make the mistake I did. I flip-flopped these at one point. The P wave is 3,500, S wave 1,700. Are you guys close to mine, like within 100 at least?
This is where we stop.
So you got this one was 3,200 and I had 3,500. Let's check it out. So 620. So when I go to 620, go over to the P wave. Yeah, you did it wrong, not me. I think what you may have done, I'm not sure exactly what you did, but 3,200 would be that would be right here at 6 minutes. Maybe that's what you did, because it is perfectly 6 minutes, not 6:20. Okay. Then I have 5,200 for that one and 2,400. Close to your answers. Are they the same? Earth. 6,900, 3,100. 3,100, 1,500. And then 6,200, 2,500. If they're flopped, you did it wrong. Or did I do it wrong? No, I didn't do it wrong. Because the P wave can always travel farther than the S wave. Yeah, I told you so. That's the way I checked. If you just heard what I said to Sam to make sure I didn't screw up, is I'm like, oh, I could have messed up, but then I looked. Remember, the P wave's always faster, so it can always travel faster than the S wave can. Or not faster, I'm sorry, farther. Imagine if any of you guys run track. No, none of you. Okay, so imagine there was a track runner in here. And we're gonna pretend Phoenix, Phoenix, we're gonna pretend you're a track. You probably are faster than me anyway. But imagine me and Phoenix were both in a race, and this is a weird race. It's a timed race. So if we both were given 9 minutes and 40 seconds to run a race, who'd get farther? Phoenix, okay? Phoenix, no matter what, any of you could probably go farther than me in 9 minutes and 40 seconds. So Phoenix is gonna go farther because he's faster like the P wave. I am not gonna go as far because I'm slow like an S wave. So you can always double check, okay, the S wave does not go as far. Phoenix and Remy, come on, say it with me, okay? Because Phoenix, you missed this, but this is the hardest stuff we're gonna do all year. And if you don't understand it now, you're not gonna understand tomorrow's stuff and then the next day's stuff. So I need you to stay on top of staying with me today. So still believing me that it's the hardest stuff you're gonna do all year? Nope, good, I like that answer. We are gonna get right now into the first thing that's a little weird, okay? And if you can see here where it says determining the difference in arrival times between P and S waves using the chart. What does that mean? Determine the difference between P and S waves. No, I'm not going to, not the same. What's it mean like in math if I ask you to determine the difference? What would you do in math if I said determine the difference? What math would you do? So, okay. You would use subtraction if I said determine the difference. And I think by now you guys know my disdain for math. Okay, well, I didn't say I hate it, but if I can avoid it, I will. And scientists in general will do that. If there's a way to avoid something and still get the correct answer, oftentimes scientists will do that. And one reason I say I avoid it is not because I'm bad at it, but because math leads me to sometimes making a stupid mistake. How often do you guys like add, subtract in your head? Because you're like, I've been doing this since I was a little kid. I can do it. And then you get it wrong. Like if you add 13 or 8 plus 5 and you're like, okay, that's 14. Anybody ever make that mistake? Just a simple mistake. Or vice versa, 13 minus 8 equals 7. Just make quick, easy ones that you know the answer. but you make a simple, quick mistake. And that's where people will go wrong doing math for this. So some of you might have already on Friday started doing math because you're like, I know how to do this, I'll do math. And if you got it right, more power to you, but I will not explain how to do math for this part. I'm going to teach you the way to avoid math for this section. Sound good? Everybody here okay with? No, I didn't say teach you how to avoid doing math homework. I said teach you to avoid math using this. So math leads us to making a couple easy mistakes. So I'm going to show you how to avoid it. I had asked you to grab scrap paper. If you haven't, go get some fresh scrap paper. Well, it doesn't have to be fresh because I think you picked some up the other day and didn't use it. But if you didn't, go grab some scrap paper. Yeah, even if it's got a little bit of writing on it, you're good. So one thing I want to point out is, here's the P wave. Oh, guys, I'm already teaching. So here's the P wave, here's the S wave. The difference is always going to be the space in between the P and the S wave. Do most of you guys have a pencil right now? Okay, I'll hook you guys up if you have a pen. I'll get you a pencil. Well, what I'd like to do before we even start this is I would like to lightly shade. Don't make it so dark that you can't see, but could you lightly shade this space in between the P and the S waves? So if you just saw how I did that, I just went real quick with the edge of my pencil. Don't go dark because you do need to see underneath there. Who needs a pencil to do this? So whatever one you think you're going to use, I recommend using the big sheet. We'll do it anyway because I asked you to do something you haven't done it yet. So do what I've asked you to do. So what you're coloring is the space in between the P and the S wave. What you're literally coloring is the difference between the P and the S wave. And I'm going to show you once we get finished coloring here what I mean. So again, be careful that you, be careful that you can see underneath it. You want a pencil? Did I miss you? I'm sorry. I'll give you just a little bit more time to color. If you don't finish your shading because you're a little more particular than the rest of us, you can do it at home. So that space in between, again, here's the P wave, here's the S wave. What you just colored is the difference between the two of those. So for these questions, we really just need to figure out how big that space is. And I'll show you a few tricks for doing that. But in the meantime, there are 4 steps that I would like you to write these steps perfectly word for word this one time so that we have beautiful notes and directions in our packet. So the directions for determining the arrival time difference between the P and the S waves. Step 1 is you're going to find the distance on the bottom of the chart. So again, what this is we're going to know, okay, the earthquake is 8,000 kilometers away from us. How long in between when the P wave gets here and when the S wave gets here? So that's the difference in arrival times. And the first thing you're going to do is to find that distance on the bottom of the chart. Hey, what chart am I talking about, by the way? Yeah, if you did not know what chart I was talking about, please add in ESRT page 11 to that notes. So when I say find the distance on the bottom of the chart, I mean on the bottom of ESRT page 11. Your second step will be to take your scrap paper and place it vertically, which means up and down for that distance. If you know what vertical means, you don't have to put the up and down part. So what we're gonna do is we're gonna write these notes, then take the notes and practice. Are we ready for step 3 or not quite yet? All right, step 3. Mark the scrap paper where the P and S waves touch it. How should we, I think we used up too many pencils coloring, didn't we? All right, and step 4, you ready? Step 4, this one sounds really weird until we practice it. You'll completely understand it once we practice, but again, it's a little weird. Move the scrap paper to the left side of the chart. Place the mark for the P wave on the 0 and read the time using the S wave mark. So write that in there and then we'll go practice it. Let's give this a whirl. Grab your scrap paper, grab your packet, grab your reference table page. I'll wait for everybody to finish writing this and then we'll go practice. Looks like we're ready. So I am using my small one, which is a little harder for me to see, but that way we can get the whole thing on the screen so you can see. So we're going to do the first problem on the bottom of your packet where you were just writing. It says again, determine the difference in arrival time for each of the following. So we know the earthquake is 8,000 kilometers away from us. We want to know the difference between when the P wave gets there and when the S wave gets there. So we're going to follow those steps that you just wrote. So step 1 says find the distance on the bottom of the chart. So again, the one we're doing is 8,000. So step 1 is literally just pointing to 8,000. Step 2 is to place your scrap paper along that line. And can I give you a hint? Because this is not my first time doing it. Take your scrap paper and there's the 8,000 line. Line it up so that your scrap paper is to the right of the number 8,000. And for you lefties, this is another time where this gets probably uncomfortable for you. So what I think a lot of people do, especially my people who are left-handed, you put the scrap paper on the other side of the 8,000, covering up the smaller numbers. I'm going to tell you it's easier in the long run, even if you are left-handed, to put your paper so we're just to the right of the 8,000. So everybody do this. Take your scrap paper, put it along the 8,000 line. Step 3 said to mark the scrap paper where the P and the S waves touch it. So here's the P line, here's the S line. What I want you to do, and you might have to like rearrange your hands a little bit, is mark off where that P wave comes in contact with your scrap paper. And you may, hey, Chris, do you mind turning the lights off for me? So notice how I'm making just little marks. Mine are bigger just to show you. Thank you. That look a little better. So see how I did not just continue the line up. I made little horizontal marks on my scrap paper. So,
Make sure paper's straight. too.
ooh, yes. So make sure it's completely lined up with that 8,000 line. So we are all using the small ones. Your scrap paper will literally look identical to mine. If you're using a bigger one, it'll still look, it'll just be a bigger space. So you've got those 2 marks. Again, they line up perfectly where the P and then where the S wave touch it. If you want to label it P and S, you can. You might want to for this time, but you're going to see you don't really have to. Then step 4 said to take your scrap paper to the left of the chart and line up the P with the 0. So I'm going to take where my P mark is and put it at 0. And then it says you can read the time using the S. How many seconds? Should be right at the 1 line past 9, which would be 9 minutes and 20 seconds. A few people might be a little bit higher, but probably not up to the 9:30.
How would it be 9?
What do you mean, why would it be 9 minutes and 20 seconds? Because it's 1 line past the 9. Nope, because these go up by 20 seconds. 20, 40, 60 seconds starts a new minute. Which is something you missed on Friday. So you should go back to the video on Friday and do some labeling like we did in class. So what's the difference? 9 minutes and 20 seconds. That's the first question on our practice. So again, if you noticed, I should have pointed this out, we really marked off how wide that shaded area was. That's the difference from when the P wave gets there to the difference when the S wave gets there. That's what we measured. So you were measuring the difference. Now, of course, you could do math, but I'm not going to teach you how. And it does leave you open for making a couple of mistakes. So I think we'll see how long it takes, but I think this is what we're going to do for the rest of today. You are going to finish these 2 bottom charts. So there's one on the left and one on the right. Mr. D and I are going to come around with the answer key and look over your shoulder. So please don't feel insulted if we tell you you did something wrong. This is right where we're going to pick up tomorrow. I might, if everybody finishes, I'll put up the answers when we're done.